Hi everyone, my name is Mahmoud Hammad. I'm an assistant professor at Jordan University of Science and Technology. I will be presenting our paper entitled Tool Assisted Componentization of Java Applications, co-authored with Ibrahim Abueisa, a software engineer at Amazon, and Sam Malek, a professor at UCI. So as you know that the object-oriented programming languages, they support object-oriented constructs such as packages and classes and methods. But unfortunately, they don't explicitly support component-based constructs such as components, connectors, and ports. Hence, we face a lot of problems, including architectural erosion or architectural drift, in which the prescriptive architecture, which is the design architecture, does not match the descriptive architecture, which is the implemented architecture, especially as the system evolves. So there's the solution for the Java solution for that is that 5 years ago, Java introduced the Java Platform Module System, or JVMS. So the JVMS explicitly supports the components, which is called modules, and the ports, which is called module directives. Unfortunately, they don't explicitly support connectors. JVMS itself also is modularized, meaning that you can require a subset of the JVMS and hence reducing the memory footprint of your application at runtime. However, most Java applications are still object-oriented applications. They are still using the JDK8 and prior versions. Even the Java 9 application or the applications that have been converted to JVMS, out of our analysis of 1,300 open source applications, we found only 33 Java applications are utilizing JVMS capabilities. We also found that most of the software engineers, when they convert their object-oriented application to a component-based application, they put all the application in one module, in one component, resulting in an overprivileged architecture. So in which all components they can communicate with one another, and all components they require all system components. So we believe that the reason behind that which is why do software engineers they don't convert their Java 8 applications to component-based applications is the lack of tools to assist developers in converting their object-oriented application to component-based application. Therefore, we are proposing our approach named OO2CB, object-oriented to component-based conversion tool. So next, I will give an illustrative example and use it as a background to know the JVMS and present our approach, evaluation, and then conclude the presentation. So as you can see here, this is part of the object-oriented application of a university system that we have created for demonstration. So as you can see that the STU schedule class, it uses the java.util.logger system class, and also it uses the iStudent interface, which is implemented by graduate and undergraduate classes. So those are classes and interfaces, and the communication between them is just method invocation. So this is the object-oriented architecture, whereas the diagram here shows the component-based architecture of the same system. So in order for the service provider component to implement the iStudent, the STU service component needs to export the people package, which is the package in which the iStudent in. So once the student service provides the implementation, once the service provider implements the iStudent interface using the undergraduate and graduate classes, it provides these implementation to STU service. In order for the registration component to use another module, it needs to require that module. So here registration requires the STU service, which is application component, and also it requires the java.logging, which is a JVMS or system component. So since registration uses the interface iStudent, it uses that interface, and also STU service needs to export that package, the people package, to registration. All of these information in the JVMS are included in a configuration file called module-info.java file. So our approach consists of 4 steps. in which the first step, the component determination step, it takes an object-oriented application and it determines the components and the classes in each component. So we have three determination options, either fully automatic using a component determination tool. In our research, we used Arcade framework with 5 well-known component recovery tools. Another option is that we can and automatically determine the components and the classes that constitute each component, and then the developer would adjust these components and the classes, or purely manual, in which the software engineers provide that our tool provide our approach with the components and the list of the classes for each component. So the second step is the dependency analyzer, in which it takes the information from the first step and also the binary code of the object-oriented application. It creates a polygraph of the application, and then it traverses that polygraph in order to determine the dependency between the various components, the intercomponent communications, which is the communication between various components of the application, and the system communication, which is the communication between the application components and the JBMS system. So it's worth me mentioning that it's there's a difference between the Java 8 application and the Java 9 application, and the mapping is not one-to-one mapping. So there's no sufficient documentation of this mapping between Java 8 classes and Java 9 classes, and this process is tedious and error-prone. So what we did is a semi-manual solutions. We automatically mapped the Java 8 to Java 9 application when possible. Then we did a manual matching after studying the class implementation, Java documentation, various online resources. We were able to manually map 198 Java 8 application classes to Java 9 classes. After that, we left with 41 unmapped or unmatched classes. Some of them actually they have been reported as a bug report in the Oracle website. So for example, this class does not have any equivalent class in Java 9. So the third step is the configuration file builder, in which it takes the information from previous steps and it determines the required ports between various components following the least privilege security principle. So component A can communicate with component B only if there's a need if there's a real connection between these two components. So this step, it builds the module info.java file. It determines the ports following the least privilege security principle. So for the example, instead of just exporting the people package, ICSA service exports the people package only to registration. So we have seen in the open source projects that most software engineers, they just export the package, which may mean that all other components, they can use it. Which actually increases the attack surface. So it results in an overprivileged application, and it increases the attack surface of the application. And the last step, it creates the component-based application. It creates the required directories. It modifies the headers and imports sections. So the result out of this step is a component-based application applying the least privilege security principle. In terms of the evaluation, we have evaluated our approach using 4 research questions. I will introduce here, I will present here the first 3 research questions. So the first research question measures the effectiveness of our approach. So we have used five large real-world Java 8 applications, in addition to our demo application, the university system application. So as you can see, on average, we have each application has 1,194 classes, 98 components. And as you can see in the last column of this table, that all of these applications, we were able to successfully convert them to component-based applications, and we were able to compile them successfully. The second research question measures the attack surface reduction, and in this research question, we compared between the component-based application produced by our approach with the overprivileged component-based application, in which all modules are allowed to communicate with one another, and each module is requiring all the system components. This is actually the common behavior that we have seen in the open source Java projects. So in terms of the intercomponent communication, we were able to reduce with the intercomponent communication by 87%. In terms of the system communications, which is the communication between the components of the application and the system components, we were able to reduce that by 97%. And also we were able to reduce the number of required system modules by 91%. So instead of requiring all the system modules, we are requiring only subset of those modules, resulting in reducing the size of the application and also reducing the runtime of the application. So the third research question, actually, since we determined only the required system modules, the footprint of the application at runtime is reduced. So we were able to reduce the runtime for the memory footprint of the application by 65%. In terms of the threats to the validity of our approach, so the false positive produced by the static analysis tools that we used, it might be a threat. Those static analysis tools, they overestimate the applications, hence resulting in more communication than actually needed or than actually needed in the system. The included object-oriented applications, they might not be representative of all Java 8 applications. We try to use large real-world object-oriented applications. The use of the component recovery tools, yes, it's a threat, but also we are allowing the software engineer to manually adapt or manually adjust these components along with their classes. So that's actually why we call our approach tool-assisted componentization Java application. So in conclusion, I have presented our approach, which is a system for determining the least privileged architecture of an object-oriented Java application and its conversion to a component-based Java application. The determination of the least privileged architecture reduces the attack surface and also reduces the software bloat. Our experimental results show the effectiveness of our approach in converting object-oriented application to component-based application, reducing the attack surface and reducing the software bloat. Thank you so much.